Good day, everyone. We are here to present our assignment 5 made by Louis J. Bahian and Chris Abelia. To start, modern computing demands high speed, responsiveness, and efficiency. Single core processors can no longer keep up with these needs. This is why almost all modern CPUs use multi-core organization, which means having multiple processing cores inside one chip. Each core can handle different tasks. This makes the system faster, more efficient, and capable of running many applications at the same time without slowing down. In this presentation, we will show two real examples of how multi-core architecture is used in current processors. We will discuss two multi-core processors, which is the Intel Core i7-12900K and AMD Ryzen 9 9950X. So, what is a multi-core organization? Multi-core processors contains two or more processing units or cores inside a single CPU package. These cores can work independently for multitasking or work together for parallel processing. For example, one core can play a video and another can manage background updates while another handles a game. This increases overall processing speed, efficiency during multitasking, performance in applications that use many threads, and energy savings because not all cores need to run at full power. So, this concept is a key to both processors that we will discuss. So for our first computer model, we have here the Intel Core i7-12900K, based on the Alder Lake architecture. What makes Alder Lake unique is that it uses a hybrid multi-core design where it combines 8 performance cores or P cores and 8 efficiency cores or E cores. So the P cores are designed for heavy workloads like gaming and rendering, while the E cores are designed to handle background tasks and improve efficiency. The processor also includes an Intel Xe GPU, AI acceleration hardware called GNA 3.0, and support for new technologies such as DDR5 memory and PCLE 5.0. So, So how does the multi-core system work in this processor? So this hybrid architecture works through a special feature called Intel Thread Director. The Thread Director monitors each task and decides whether it should run on a P core or an E core. For example, if you are gaming, the game engine will be handled by the P cores for maximum performance. And if Windows perform background updates, those tasks will be assigned to the E cores. This automatic distribution prevents slowdown and improves battery efficiency in mobile versions of the processor. This shows how multi-core design is not just about having many cores, it is also about using them intelligently. In terms of performance, the P cores can boost up to 5.1 GHz, giving excellent single-thread performance for demanding tasks. The E cores boost up to 3.9 GHz, efficiently handling multitasking. Intel also uses Turbo Boost and RAPL to manage power and prevent overheating. Because of these features, the 12900K performs very well in gaming, video editing, productivity, and even AI assisted tasks. It delivers a strong balance between performance and efficiency, which is the main advantage of its multi core design.
The next processor is AMD Ryzen 9 9950X, part of the Zen 5 Granite Ridge family. So unlike the Intel's hybrid design, AMD uses a chipset-based multi-core architecture. The processor has 16 cores and 32 threads, divided into two core complex dies, or CCDs. So each CCD contains 8 Zen 5 cores and 32 megabyte of shared level 3 cache. So these CCDs communicate with an IO die which contains the memory controllers, PCI lanes, and integrated graphics. So these setups improves scalability, heat distribution, and overall efficiency. The CCDs connect to the I/O die through AMD's Infinity Fabric. So this allows the processor to transfer data quickly between cores and memory. Zen 5 cores include improved scheduling, larger execution pipelines, and a better floating point performance. So this means that the 9950X is optimized for heavily multi-threaded workloads such as the video rendering, 3D modeling, scientific simulations, and large-scale software compilations, while Intel focuses on the mixing performance and efficiency cores, AMD focuses on maximizing raw multi-core throughput. The Ryzen 9 9950X operates at a base clock of 4.3 GHz and boosts up to 5.7 GHz, so it has extremely fast cache performance with up to 1.4 terabytes per second of level 3 throughput. Its level 1 bandwidth exceeds a 10 terabytes per second, which helps speed up memory intensive tasks. It also supports full EVX 512, which greatly improves performance in vector-heavy applications like encoding, simulation, and compression. It real tests such as video encoding and Linux kernel compilation. It showed 15 to 27% improvements over Zen 4 thanks to its enhanced multi-core design. Now, let's talk about how multi-core design improves system performance based on both processors. Parallel processing. So multiple cores allow tasks to run simultaneously, greatly improving its speed. So in two, energy efficiency, hybrid cores Intel and efficiently triplets AMD reduces the power consumption. Three, better multitasking. So background tasks stay smooth without affecting the foreground performance. Four, the thermal management. So the workloads are distributed, reducing the heat concentration. In conclusion, multi-core organization has transformed modern computing by enabling faster, more efficient, and a more capable systems. The Intel Core i9 12900K demonstrate intelligent workload management with its hybrid P-core and an E-core architecture. So the AMD Ryzen 9 9950X shows the power chipset design and throughput-oriented multi-core performance. So both of these processors highlight how multi-core architecture boosts performance across everyday tasks, professional workloads, and high-end computing applications. Thank you.